Now it's winter, and our basketball court is outside, so I can't play basketball outside right now. And I decided to make this miniature version so that I can always play it. Once in class, Maxim came up with the implementation of the project and showed me a video. The video first showed his desk, his workplace where all the parts and various measuring devices were, and when turned to the right side, where the cardboard alpha version of this project was placed. As soon as there was an opportunity for the children to create their projects, I immediately remembered this video and offered him to make a full-fledged model work. The next stage was designing. I decided to make a 3D model in the 3D modeling program Fusion 360 to see how it would look in the end. After designing, we started assembling the project, selecting various parts, purchasing them, soldering, etc. Well, after these stages, I got such a good product. First of all, children received basic knowledge and lessons, and during the development of these projects, they received the experience they needed. It was challenging to find suitable housing for this model, surprisingly. If you Google a case for a project of the right size, it may not exist, so we had to make the case ourselves. There are 3D printed parts here. For example, here's this part, rear shield, here's the upper ring, and here's this whole structure that throws. These are all parts printed on the 3D printer. Another task I had was decorating. Actually, I'm not very strong in this way. Maybe this is my weakness. It was challenging to find suitable decor for this, and it can even be added as a separate point of development. In fact, all stages were interesting, and I really enjoyed creating this project. Every little particle is like a big way up the mountain. Yes, I agree that the entire logical part can be implemented on the pair of transistors, a microcircuit and a sensor, without resorting to programming at all. But perhaps the very simplicity of this project will inspire and motivate other students. I like that you can see the details however you want. For example, here the servo drive is used as throwing mechanism, and here it's already a walking device. It's only limited by your imagination. You can do anything and everything you want. You can connect here some LEDs that will light up when hit, or put a speaker that will play some winning melody, etc. The space for improvement is limitless. You are limited again only by your imagination. Another project I've been working on is a lab power supply. It helped me a lot in creating this project, and in general in development. It is an indispensable thing, and in fact, it's very cool that there are similar devices that can be bought on the internet. But I set myself this challenge, to make my own laboratory unit power, not buy. I made it, and it really works and helps me in designing and prototyping projects. It's really cool that there's a School of Robotics, RoboCode, where you can get to know all this, learn how to use it, and then have fun with these projects. Senior Embedded course, the third year of study, 14 years, the level of technical university coursework.